Hello class, Mr. Green here, and again I want to thank you very much for watching my review tutorial on maps, specifically latitude and longitude. I know you've all seen a lot of stuff about this in middle school and maybe even a little bit in high school, but I think it's really important that before we embark on our Age of Exploration unit, that you understand how to find the exact location of something on a map using latitude, longitude, and coordinate points. In our unit, we're going to spend a lot of time finding the exact places that explorers started, ended, and their stops along the way, as well as the distance between the 2 points that they took. So I think this will be a great review in order to really make it easier for you to understand where things are. Now, the basics of a map, besides the land masses, ocean, compass, all of those things, is the idea of latitude and longitude. Longitude are the vertical lines on a map. Even though they run north to south, they actually measure east to west. Latitude lines are the opposite. Even though they run horizontal east to west on a map, they actually measure north and south. Now, sometimes students find these very confusing, and I think the best way to remember them is the idea that longitude lines run the long way around the Earth, the top to the bottom of the oval. If you can remember that, if you just remember that latitude lines are the opposite, you should have an easy time understanding. When you put them together, you get latitude and longitude lines that cross each other like this. Now, I know this is not like a normal map where the normal Earth is actually on a curve, but for the purposes of what we're doing today, you just need to understand the fact that there are latitude and longitude lines that cross each other at some point on the map. Now, what are latitude and longitude lines measured in? Well, they're measured in degrees, which I will cover in a second. But right here, we have the idea of what latitude measures. Latitude, again, measures north to south from 0 to 90. 0 in the middle, 90 at the top, and then 90 at the bottom. From 0 to 90 degrees north, once you reach that point, it again starts moving backwards. So at the North Pole, on the other side of the Earth, you'll start going down 89, 86, 82, 50, 30, all the way until you reach 0 again, at which point you'll start saying the same thing south. At times, south is expressed as a negative, so instead of negative 90 degrees south, you would get negative 90 degrees. But I think it's important that we remember what the directions are. So in our lessons, please say 90 degrees south rather than negative 90. Longitude is a little different. It does start at 0 and moves to 90, but at 90 degrees, it then continues going until it reaches 180 degrees on the other side of the Earth. Instead of very much unlike latitude. At latitude, once it reaches 90, it starts working backwards until it reaches 0 again. Remember, longitude reaches 90, goes to 91, all the way to 180, which has no directional little symbol at the end. It's not east, it's not west, it's just 180 degrees. And then it begins to count backwards on the opposite direction. So we start at 0, move to 90 degrees east, all the way around to the other side of the Earth at 179 degrees east, reaches 180, and then we start going the other direction. It becomes 179 degrees west, 150 degrees west, all the way back down to 0. So again, remember, longitude is 0 to 180, latitude is degrees east and west, latitude is 0 to 90 north and south, and counts backwards. Now, some very important latitude and longitude lines I have diagrammed on this little map here, and what their names are. 0 is, of course, the equator, the midpoint latitude-wise between the North and the south. It runs all the way around the Earth. Everything on the zero is the equator. At the top we have the North Pole, which is 90 degrees. It has a lot of other connotations such as magnetism and ocean currents and all of that, but for this it is just the 90 degrees north, very, very, very top of the Earth. And this, in the south, we of course have the South Pole, which is negative 90 degrees or 90 degrees south. These are the middle and the tips of the world. Two other very important latitude lines that we will probably reference to many a time in our studies here is the 23.5 degrees north and 23.5 degrees south lines. These are called the Tropics of Capricorn and the Tropic of Cancer. These two lines are the two places, have several meanings, but one of them being these are the farthest north and the farthest south points that receive direct sunlight at any point in the year. Other times, everywhere else receives at some angle, which means there's less of it. But for our purposes, these are also the places where a lot of the early exploration is done. This is the very section that the Caribbean is, where Christopher Columbus did a lot of his first discoveries, and Capricorn is very much at the tip of South America, where explorers such as Pizarro and Cortez found a lot of their interesting things that explorers find. At the same time, we have the two important longitude lines are the prime meridian and at 0 and at 180 the international date line. Everything east and west of the prime meridian starts at 0 and goes 1, 2, 3, 4 until it reaches 180 at the international date line, which is where the day changes between Monday and Tuesday, Tuesday and Wednesday, where everything begins to move backwards 179, 178, both directions. Now, what is a degree, and when you put latitude and longitude together, what does it make? Well, when you put latitude and longitude together, you get a coordinate point. This coordinate point is some random place in Nigeria. There's no importance to it, but really, I really want to show you that there's really two ways you can state an absolute location. Here we have 6.17 degrees north, which means it is about 6 degrees north of the equator, and 8.12 degrees east, which means it's about 8 degrees east of the prime meridian. The issue with this is the fact that we don't really know what a degree is, and even finding 0.17 of a degree would be very difficult for us to do. That is why we have the metric method of finding a location. Now here we have 6 degrees 10 minutes 12 seconds north, 8 degrees 7 minutes 30 seconds east, which at this point sounds very foreign to you, but I'm going to explain to you what a degree, a minute, and a second really represent. First, the symbols. A degree is the little circle right there. A minute is a single slash, and the seconds are the double slash. The best way to think about it is to think about very much as time using degrees instead of hours. A degree is equal to 60 miles. So the difference between 1 degree and 2 degrees is 60 miles. The difference between 1 degree and 3 degrees is 120 miles. So degrees is 60 miles. A minute is 1/60th of an hour, and it is also 1/60th of a degree. So every minute is worth 1 mile. So, back to this map, we have 10 miles extra off of 60 times 6, 360 degrees. Miles are there. A second is still 1/60th of a minute, so 1/60th of 1 is about 90 feet, this is really small numbers to which to go from. So, 60 miles, 1 mile, 90 feet, and that's the best way to really measure how far something is away from something else. Just for our final example, as I wrap this up, we have ourselves the exact coordinates of our hometown of Big Rapids. Big Rapids is 43 degrees, 42 minutes, and 0 seconds away from the north of the equator. That is very close to halfway between the equator and the North Pole, well, in the northern hemisphere. It is also 85 degrees, 28 minutes, and 48 seconds west of the prime meridian. Again, this could also be expressed as negative 80 degrees, but again, just use north, south, east, and west. This is very close to halfway to the international dateline, which would put it a quarter of the way around the world from the prime meridian. Well, I hope you can really use this information in the lessons to come as extra credit to prove that you've watched this online tutorial. I want you to go find a random place in the world. As long as you name what it is, you can use it. So, finding the Gaza Pyramid. Look up on Google Maps, type in the Gaza Pyramid, and find the exact absolute location in degrees, minutes, and seconds, and bring it to class. If you do that, you'll get 5 extra credit points and really prove to me that you have paid attention to this online tutorial. Again, I want to thank you very much. I hope that the Age of Explorers is very interesting to you, and I hope that this lesson helps you with the maps in the future. Thank you very much, and I'll see you guys tomorrow.